I'm J. Anzano. I'm electrical 1D.
Hi everyone, my name is Aaron M. Corbo.
Good afternoon, sir. I am Racaza from Section 1D.
Good afternoon, guys. I am Dave Murillo from Electrical Engineering Department, Section 1D.
Hello sir, I'm Jen Clifford C. Sanico from 1D Electrical.
Introduction to metals. Metal possess many unique fundamental properties that make them an ideal material for use in diverse range of applications. Properties such as height, tensile strength, high fracture toughness, malleability, and availability are just one of the advantages associated with metals. Metals generally malleable. They can be hammered, permanent or shaped without breaking or cracking, able to fuse or melted and ductile. Metals in the have high electrical conductivity, high thermal conductivity, and high density. Metals are generally not used in a pure state but are mixture of metals or metal and non-metal continuous and commonly referred to as alloys. Mechanical properties of metals include ductility, i.e. their capacity for plastic deformation. Reversible plastic deformation in metals can be described by Hoff. Low for restoring force, where the string is barely proportional to the strain. Words larger than the plasticity are hit, meaning of permanent deformation. The object known as plastic deformation of plasticity. Both metals are still compared because of some search, such as size or stroke height. The first were discovered at Italy more than 500 years ago. Definition of metal is a material, an element, compound, or alloy that is typically hard, opaque, shiny, and has good electrical and thermal conductivity.
Our topic today is metal. Below comparison between metals and non-metals. Metals, good conductor of heat and electricity. Non-metals, pure conductor of heat and electricity. Malleable, can be beaten into dense sheets. Non-metals, brittle, if solid. Metals, ductile, can be stretched into wire. Non-metals, non-ductile. Metals, possessed metallic luster. Non-metal, not possess metallic luster. Metals, solid and room temperature, except Hg. Non-metals, solid, liquid, or gases at room temperature. Property, appearance. Metals, shiny. Non-metals, dull. Property, melting and boiling points. Metals, height, they are all solid at room temperature except mercury, which is a liquid. Non-metals, though they are metals, bromine is a liquid at the room temperature and 11 other is gas. Density, high, they are feel high for their size. Non-metals, low, they are feel light for this size. Pure property, strain. Metals, strong, they can hold heavy load without breaking. Non-metals, nothing strong. Property, malleability. Sa metals, malleability. They can be humbled into different shape without breaking. Non-metals, brittle, they break or shape when hammered. Property, ductile. Metals, ductile, they can be grown out of to make wire, non-metals, non-ductile. Property, heat conductivity. Metals, good. Non-metals, poor. Property, electrical conductivity. Metals, good. Non-metals, poor. But rapid, a form of carbon, is an expansion. Metals, silver, Ag. Terminal conductivity 4.29 watts. Electrical resistivity 1.59 resistor. Metal, copper, Cu. Terminal conductivity 4.01 watts. Electrical resistivity 1.67 resistor. Metal, iron, Fe. Terminal conductivity 0.804 watts. Electrical resistivity 9.71 resistor. Metals, vanadium, V. Terminal conductivity 0.307 watts. Electrical resistivity 24.8 resistor. That's all.
There are 4 types of metals, which are noble metals, alkaline metals, alkaline earth metals, and transition metals. When we say noble metals, generally unattractive, for example, silver, platinum, gold, and palladium. When we say alkaline metals, it is very reactive with a low melting point, and it is soft, for example, potassium and sodium. When we say alkali earth metal, it is less attractive but higher melting points and harder than alkali metals. For example, calcium, magnesium, and barium. When we say transition metals, it is hard, shiny, and strong, and easy to shape. For example, iron, chromium, nickel, and copper. There is the general properties of metals, which are good conductors of heat and electricity, and a high malleability and ductility.
So today we are going to discuss the chemical properties of metals. As we all know, there are 2 types of chemical properties. One is metals and the other one is non-metals. Metals have a tendency to donate electrons, while non-metals have a tendency to receive electrons. Metals displace hydrogen gas from dilute acids, just like this formula, while non-metals don't displace hydrogen gas from dilute acids. Metals react with oxygen to produce basic oxides, just look at this formula, while non-metals react with oxygen to produce acidic oxides, and take a look at this formula. Metals react with hydrogen to produce hydroxides, just like this formula, while non-metals react with hydrogen to produce covalent compounds. Just look at this formula. So now, let's proceed to material properties of metals. As we all know, there are lots of properties of metals. Number 1 is mechanical. Mechanical consists of strength, toughness, ductility, hardness, electricity, fatigue, creep, and ratios. The other one is physical. Physical consists of density, specific heat, thermal, expansion, thermal conductivity, melting point, magnetic, and electrical qualities. The third one is chemical. Chemical consists of oxidation, corrosion, degradation, toxicity, and flammability. And the last one is manufacturing. Manufacturing consists of manufacturability, effects on product properties, service life, and cost.
Metal classification. All metals may be classified as ferrous or non-ferrous. There are 2 types of metals, ferrous metals and non-ferrous metals. Ferrous metals include cast iron, steel, and the various steel alloys. The only difference between iron and steel is the carbon content. Cast iron contains more than 2% carbon, while steel contains less than 2%. Then, the non-ferrous metals are metals that do not contain iron. Examples include aluminum, zinc, copper, and brass. In general, non-ferrous metals do not corrode as quickly as ferrous metals due to the rapid formation of a thin protective oxide layer on their surface, although they are still susceptible to corrosion when exposed to atmospheric conditions. Based off the book of Materials in Science, Engineering, it states that due to the presence of the surface oxides, non-ferrous metals have different requirement for surface preparation and priming the ferrous metals. That's all.
And now, let's proceed with the examples of elements of metals that can be seen in the workplace.
Copper can be seen in electrical, as it is used to be a wire because of its strong metallic bond. And it is also a good conductor for electricity. Copper is also malleable, meaning it can be easily machined and stretched into a wire-like form.
Tungsten can also be seen in electrical because of how it's used as a filament in an electric bulb. This is how tungsten looks like in electrical workplace. And for the semiconductor, we can use silicon, germanium, and gallium arsenide because they are known for the most common to be used as semiconductor in the workplace of electrical. This is how semiconductors look like in the electrical workplace. So now let's proceed to gold. Gold is highly conductive, meaning electricity can easily flow through it with minimal resistance. Copper, silver, and aluminum are also conductive, but gold offers a superior level of electrical conductivity.
Silver has the highest electrical conductivity of all metals, with copper having the second highest. This makes silver very useful in electronics, often being used for solder, electrical contacts, and printed circuit boards. Platinum is an element with high electrical conductivity and is more ductile than gold, silver, or copper. It is less malleable than gold. The metal has excellent resistance to corrosion, is stable at high temperatures, and has stable electrical properties.